Okay, cool. So tonight, gonna continue with study unit 3 and 4. We will in next week we'll recap some of the previous study units as well. I'll show you tonight how to use Excel for study unit 3, and then we can in the week also then focus on how to use Excel specifically for those last two chapters as well. Okay, so let me get to where we left off previously with the recap work. So last time we looked at study unit 2, and within study unit 2 there was nearly a lot of things that we needed to do in study unit 3 in any case. So I will nearly start where we left off from there, because now we go into your measures of tendency and your measures of the same as location, and then of variance and those kind of things. Okay, so within this one, and this would have been from previous questions that also looked at this data. So they are giving the data again, and what we do with the data is that they have ranked it from the smallest to the largest. They tell us in this data set there is 50 learners, so that we know that n is 50, and then they ask us a few things around this data set. Okay, so they ask us, this is weird, why is this C1? Okay, so they ask us questions around the quartiles. So there's the positioning of the quartiles. Then they ask us about the value of certain quartiles, and then some other things, including range and those kind of things. Okay, so when I see a question like this, for me, always the one that I will, I don't know what is, why suddenly there's such a delay in, let me just quickly, gonna close the screen, and open it again, and then just want to see what why there's such a big delay in. Okay, let me share again. And hopefully the delay is gone now. Okay, so if I look at this data set, the first thing, no, it's still there. Oh. I can see there's issues with my connection as well, and with Teams and everything. So this is not great tonight. But let me then just look at this. So when we look at range, it is basically the biggest number, and we subtract the smallest number. In this instance, 20.2 minus 6.2, that will give you the range. So the range is 14. So D is correct. Okay, so then we will go into the quartiles. So let's first look at what they say about the second quartile. Remember, second quartile is also the median. So the second quartile is calculating the average between the 25th and 26th observation. Remember, there's 50 observations. So we will calculate it between those two. So that is, the mean is going to be in there. So it is basically adding the two numbers and getting the average of it. So adding 12.5 and 12.5 and divided by 2 will give you 12.5. So whenever we need to work out what the median is, it is also 12.5. But the definition, nearly what they said, is correct, because your second quartile is calculated by looking at the average of those two numbers. Okay, so now we've got one that we need to work out: position 1, position 2, position 3. Okay, so when I look at position 1, hopefully I can write it now here without, okay, let me roll them, since it is now giving issues. Let me add here so basically, how are we going to work it out is, for position 1, we're going to say n plus 1 divided by 4. If we have position 2, it is going to be 2 times n plus 1 divided by 4, and then just for position 3, it will be 3 times n plus 1 divided by 4. So that will be your formulas in any case that you will need to work out. And if we do that with the first one, 50 plus 1 gives you 51. 51 divided by 4 will give you that first position. The position of second quartile, remember again, it's mean, so it's actually between 25 and 26. They give us the value. So if I said at B, the value of a second quartile is 12.5, it would have been correct. But they're saying the position is 12.5, so the position is incorrect. And then if we just looked at the last one, E, 50 plus 1 gives you 51 times 5. Times 3 gives you 153. And if you divide that by 4 and round it off, you will also get that the position of a third quartile is 38. So out of this big data set, they can ask you to work out quartiles. They could have asked you in this set of data to look at mode, and your median, because median was in any case second quartile. They will not ask you, without giving you more information, to work out the mean in this instance. Then they probably would have given you the sum of all of it, and then they can ask you to work out the mean, but they're not going to ask you on 50 points to work out the mean. They're not going to ask you on 50 data points to work out a standard deviation or variance or anything like that. So when you get a big set of data like this, the things that they will ask you is your quartiles. They could have asked you interquartile range. They can ask you minimum, maximum, and range, but they will not go into the other types of measurements, because it will just take forever. Even if you have Excel and you need to do this, it really is going to take you quite some time, and then it's very easy to also make a mistake when you need to look at the data. So they will not, in the exam, give you such a big data set for things like mean, variance, and standard deviation. Okay, so now we go back to stem and leaf. So they love stem and leaf. And just some other things. I think we nearly covered all of this in the previous time as well. But to look at the things that they will ask you about the stem and leaf. So other things that they normally will ask. So they ask you in this instance the range. So again, range, the maximum 86 divided by minus the minimum 36. So that is 50. They can ask you what's the minimum number. They can ask you what's the maximum, so they don't need always to ask the range. What they also love to ask is something like this in a second option, where they say the fifth largest number or the fifth smallest number. Very important with that. So when we look at largest, we need to work from here. When we get smallest, we need to work from here. And that is nearly, sometimes it's very easy to say fifth largest, okay, 1, 2, 3, 4, 5, 50, 50 it is, and you say that's correct. Okay, but it's not, because the fifth largest is actually from the other side. So it's 1, 2, 3, 4, 5, so it's 80 and not 50. But very easy to make that mistake in this instance, because one is so accustomed to start counting at the top, but not realizing that your biggest numbers is actually at the bottom of the graph. Okay, then 33 numbers. Yes, that will be correct. You can count it. It will be the mode. Mode, the number that happens the most. So if you look at, that's all single numbers. So there's a 51 that happens twice. There's a 55 that happens twice. There's a 64 that happens twice. And then there's a 70 that happens 3 times. So 70 is the mode. If 70 was also 2 numbers, then you nearly have 1, 2, 3, 4 modes. So then I need to tell you the mode is 51, 55, 64, and 70. So if 70 only had 2, I needed to then give you a wider range of numbers that actually are all modes. So just keep that also in mind. If there is more than one mode in your options set, they must also give you more than one mode. Then the median 64. So we know there's 33 numbers. So around number 17, we will have a median. So let's see, 1, 2, 3, 4, 5, 6, 7, 13, 14, 15, 16, 17. So you can see where it is 64. So the median is 64. Okay, so you didn't need to work out anything. Previous question, you needed to work out a bit of information with the formulas. Here it was nearly more simpler and to read off what is in the stem and leaf. Okay. It's seldom ask quartile work in stem and leaf. It's just not, I haven't seen any in previous questions. So I rather give you a data set like this and ask you the Q1s and Q3s. I haven't really seen that in a stem and leaf they ask that. Okay, so this one I'm going to skip. I'll start sharing some of these slides with you. Very similar, so you could see that was out of one exam paper. This one was out of another exam paper. And all that they needed nearly changed was two options. So not going to go through this one, but I will share this back with you guys in any case. Okay, what they also tend to give you is data, and then they will represent it in a stem and leaf. What they also love, and you guys would have seen that, I think in a previous, or we still will do it, where we look at the box and whisker as well. So that is one of the things that we love to ask in a paper, by giving you data and then give you options of how this data set is represented. So here they give us the data, then they tell us which one of the following stem and leaf diagrams best represents the data. A hint, round up 18.5 and 30.5. So that one we need to round up to 19. That one we need to round up to 31. This is actually stupid they should have just done it in the table. So normally this will already have been rounded up, but if not, just remember that tip that they have given you. Okay, so then they give us 5 options. So nearly the first thing that we look at is the stem correct before we even go to the leaves? So 1 to 3, so that might be one that we can work with. 1 to 2, okay, so definitely not. 10, 20, 30, definitely not. 1 to 3, okay, could be. Ooh, can anybody else see my screen? Okay. Okay, so it's everybody else can see it. I wonder, maybe Queen, you need to, like I needed to exit and rejoin. Yeah, that's probably. Okay. Then let's just look at the stem 1 to 3. So that might be 1 to 3. That might be. Okay, so there's 1, there's 2, there's 3 options that could be. So let's look within it. Sorry. Okay, suddenly now within it 19, 22.5. Okay, so that is definitely not something that we can work with. 8.5, they told us we need to round up. So again, we'll not be able to work with that. So we actually left with 1. We haven't even looked at the finer detail of a data, but we are actually stuck with 1 option. So let's look at it if it is in any case correct. So 19, yes, that is 19, 20, 22, 25, and then 31 because 30.5 was rounded up. Okay, so a bit of a different question that they've given here. Again, it's stupid that they haven't rounded it off automatically for you, because that just makes it that if you don't then read everything and you just look at it, one might have gone to one of these options already. Because again, sometimes we look at the data and we assume the representation without even reading some of the wording. Okay. Next one. So what we've done now here is they again stem and leave, ask a few questions, and then they also include a bit of a definition question. And I've seen more of these types of questions coming through. So let's do the easiest one first. Let's look at the range. Range is 73 minus 41. Okay, so that is 32. Okay, they tell us there's 2 modes. So let's look at the options of the modes. Okay, 52, there's 2 of them. 65, 65, 66, 66. Okay, so they only mentioned 2 of it. They haven't mentioned the 3rd one. So yeah, it is wrong because we also needed to include 52 as part of the modes. Okay, so that was nearly what I wanted to explain in one of the previous questions. But let's just look at the others as well. 5th largest. So again, remember large, we move from this side. So 1, 2, 3, 4, 5. The 5th largest is 66. The median is 61. Can you tell us how many? So we've got 17 cars. So 8 on the one side, 8 and the 9th car. So 1, 2, 3, 4, 5, 6, 7, 8. 9th car is 61, so our median is 61. And then they tell us the mean is the measure that is affected by outlier. So let's first look a mode. So if here was a number, let's say 91, we can see it's an outlier. The mode would not have been affected by it. The median would not have been affected by it, but the mean is the measure that will be affected by the outlier. Okay, so remember the mean will be affected. If we look at what other measures will be affected, your standard deviation and your variance will also be affected. So if we look at measures of location, it's only the mean that will be affected. But if we look at measures of dispersion, you will automatically see your range will be affected, your variance will be affected, and your standard deviation will be affected by an outlier. Okay, so that is just if I actually ask around outliers on measures of dispersion for you guys as well. Okay, so let's go down to some more. Okay, so again, this was out of one of the previous exams. Um, Consider a sample of size of 13 observations. In an ordered array of these observations, which one of the following statements best describe how to determine the quartiles of the sample data? Okay, so 13 observations. The first quartile is given by observation 3. The third quartile is given by observation 11. The first quartile is calculated as the average between observation 3 and observation 4. The third quartile is calculated as the average between observation 11 and observation 12. The second quartile is given by observation 8. Okay, so think about this one. If you want to grab a paper, write it out, but we see what we get for this. And then we can. So how would you guys have solved this? They say which one of the following statements best describe. Okay, so before we look at first and third, second quartile is your median. If you have, cool. So we will use that formula set. So we will use the n+1 divided by 4 for quartile 1, and then 3n+1 divided by 4 for quartile 3. So the 13 plus 1 divided by 4 will give us like something like 3.5. If we have it times 4, or 3 times 14 is that 52 divided by 4. Okay, so this is interesting. So so if we first work out quartile 2, which is a median, the number that it should be is 7. So it's not that one. If we look at the first quartile is given by observation 3, not really, because when you work it out, 13 plus 1 is 14 divided by 4 gives you 3.5. So it's actually between observation 3 and 4. So it would have been that one. So again, when we use the formula for quartile 3, it would have been 3 times 14, which will give us 42. 42 divided by 4 gives us 10.5. So it's also not that one. And if I lose some connection now, it's because of load shedding, but it will be back up in a few minutes. But it seems like I'm actually fine. Okay. So then for D, if it was between 10 and 11, it would have been right, but they say between 11 and 12. So that's why that is also also incorrect. Okay, so perfect. Use the formula set that we've looked at, and then we get to the answer. So perfect one there. Okay, a next set. Okay, and I said we won't get with a stem and leaf anything on quartiles, and so we have one. So here they give us a data set. They ask us, like with some of the previous ones, they also ask us interquartile range, but they ask us the position of the first quartile, position of the third quartile, okay, the value of the first quartile, the value of a third quartile, and which one is correct. Okay, so let's look at those values, because automatically it seems like the values for me is wrong. So the value of the first quartile, well, it can't be 2. The smallest value is 31, so it just can't be 2. The value of a third quartile can also not be 6, because your smallest number is 51, so definitely also not 6. So at least without nearly working out anything, we could eliminate 2 options already. Okay, then they talk about interquartile range, and then they give us the third and the first quartile. Interesting, if you subtract those to actually get that, so it's going to be interesting what it is. So let's look how many numbers. 1, 2, 3, 4, 5, 6, 7. Okay, so then again, let's use the formula. So let me quickly, where was that? I can just copy it over. So basically using these formulas, we only need to look at the first one and the third one. So n plus 1, we know there's 7 numbers, so 7 plus 1 is 8. 8 divided by 4 is 2. So Q1 is 43, which is correct. So this again seems like one of those ones that probably there's a lot that is correct. Position of a third one, so again, if it is 7 plus 1, it's 8, so 24 divided by 4 gives you 6. So number 6, 1, 2, 3, 4, 5, 6. Okay, so that one is also correct. And that's why I said it's very interesting, because if you subtract these 2, you also get the interquartile range. That is correct. Okay, so this is definitely one that has more than one answer. So please, if this is in your exam, then you let me know. The same, I think, when you guys now had the question around in your last assignment, it was about between the Z and the T table. So you then WhatsApp me and say, I think this was wrong. Then I will flag it with the lecturer, and he will look at it. And then if there was a mistake, that question will be thrown out. So you don't even need to take a picture of it. You just tell me, John, question 2, it feels it's wrong, so that I can flag it with a lecturer. Okay, so if at any time something like this creeps in the exam where you feel there's 2 or 3 answers, or there might be not one answer correct, you can just send me a WhatsApp so that I can flag it with a lecturer, and you will then look at it. Okay, so we're getting the same data, but now they ask us to work out standard deviation. Okay, this I am definitely not going to work out on a calculator or anything like that. My preference is Excel. So I'm just, while we're chatting, I'm quickly typing the numbers in Excel, and then I will show you what I did. So it is, so I'm just quickly looking at the data. So it's 51, 43, 63, 70, 80, 89, and 96. Okay, so let me quickly share my Excel spreadsheet with you guys. Okay, so here you will see basically the data. I just normally will call it X or something like that, but here's your 7 numbers, and they ask us to work out standard deviation. So there's 2 ways that you can do it. So the one is to say, okay, but let's work out the variance. Remember, we're working with a sample, so we work out the variance, but then we need to take the square root of that variance to get to your standard deviation. Okay, so that is the one way to get to the standard deviation. Another way to get to the standard deviation is basically to say, and I see it was rounded off to 2 decimals. It's just to say, but there's a standard deviation formula as well. Important thing is that we're working with a sample, and where you can see it will be exactly the same. When we work out the standard deviation, and let's say we used the population one, which was now the wrong one. So remember 23.77, 22.01, and 22.01 is the wrong number. And look there, 22.01 is also given. So if you calculated it by using the population standard deviation, there will be, unfortunately, an answer for you. And I think that is just, again, when we work with this data in study unit 3, when we work with sample and population later on study unit 6, 7, and 8, be very careful, because unfortunately it will be that there will be the wrong answer also. Okay, so the right answer is 23.77. If you only have worked out the variance, there's an answer for you as well. So again, be careful, because and, and I know I've done it lots of times, you're so into what you're doing, you see that number and you're like, I've got it. And you just pick it without really remembering, but I'm actually need to go a step further. But please, when you work with standard deviation and variances, again, use the Excel. And that's why I nearly, in the one that I have shared, there's exactly the same. You can just change the data, but I will share these new ones that I'm showing tonight as well. Just that you are able to play around with it and look at the ways it's being done. Okay, but when it comes to variance and standard deviation, I normally tend to want to use Excel and not at all a calculator or anything like that, because it's just so much simpler, and in a sense less problems or mistakes that can creep in. Okay, so that was on study unit 3. So study unit 3 basically, and I have chatted to the lecturer, so just a mental note for myself to get you some tips. So I will share, he said he will share with me in the next week or so tips on what will be in your exam paper. So I will share that with you guys as well. But out of study unit 3, basically, the important things is mean, median, mode, Q1, Q3, interquartile range, your range, and then standard deviation and variance. Okay, so that is the important ones. Then a lot of your questions from study unit 3 will be linked nearly to study unit 2, because you need data. So it can be all in just a data structure, like a table, or it will be in a stem and leaf diagram. Okay, so study unit 4 goes into probability. And now suddenly it becomes where there's a few ways that they can ask you and show you things with probability. So they can give you the probability where something has already been nearly worked out. They can give you, okay, so in that instance, it was also, okay, so now I don't have an example. I'll get the example later, but they can also give you where the probability is in numbers. And then we need to work out some more things around it. Okay, so let's look at what they're asking in this instance, because I don't know if you guys have seen a question like this before, where they actually give it in a probability format already and then ask some questions. And again, this was out of a previous exam paper. Okay, so they tell us in this that the majority of employees were working from home during lockdown. A team of mental health experts reported the following probabilities. So people felt secure that was working at home. So 38% felt secure at home. 18% felt secure when they were working away from home. 15% insecure when they were working from home. and 29% insecure when they were working away. And that will add to 1. Okay, so things that you might want to add already is some of the totals. What I normally do is I look at the question and then I will start completing totals instead of putting totals in everything already. So let's look at the top one we work through and let's then complete some of the totals. So the first option is the probability that the primary caretaker works from home, given that their child is securely attached. So home and secure. Okay, so we need that total of secure. So that is 0.56. Okay, so then if we look at how we write the probability, so it's the probability of home given probability of secure. Okay, so we also need probability of home, which is, what is it? 3, it's that 53. So just please check for me if I added correctly. Okay, so, and they ask us, did they tell us which one is correct, which of the following statements is incorrect? Okay, so we're looking for the incorrect one. Okay, so what is the probability that the primary caregiver works from home, given that the child is securely attached? Okay, so how would you write out that probability function? How would you guys have written that out? Any ideas? Just get my calculator to work out that. Okay, so is the first one correct or incorrect? Okay, so the probability of home, 0.38 divided by the 0.56. So remember they tell us it's given. So we need to work within that straight. So it's a 0.38 divided by 0.56. Okay, so 0.38. Ugh, I think my whole PC needs a reboot. 0.56. Oh, yeah, no, this is, um, and that will give you the 0.68. So that one is correct, but we're looking for the incorrect one. Okay, so then let's go to the next one, the probability that the primary caregiver works from home and their child is securely attached, work from home and secure. So that is already given to us. Okay, so um, remember, this is already probabilities that they've worked out for us. So it is the 0.38. If it was in numbers and not probabilities, so say that was, and I'm not just making up a number, 117, and the total was something like 400, then it would have been 717 divided by 400. So then it would have been the and divided by the total. But because this is already in a probability, we can take it as is. Okay, so that probability of home and secure is 0.38. And that's why I wanted to show you this type of question, because it's a bit different in how you calculate it from the normal ones, where one is actually much more comfortable when you get the numbers and you can divide by. Where now this actually, in some of the instances, they actually have worked out the number already for you. Okay, so that is very important. Okay, then the probability that the primary caregiver works from home. Okay, so work from home, there's the total 0.53. Okay, so nothing else. Again, say it was the insecure was 113, then we would have said, okay, add those two together and divide by the total. So then we would have said something like 230 divided by 400, nearly to get us a number. But in this instance, again, probabilities was worked out already, so we can take it as is. Okay, so once again, quite different from some of the other examples or problems you would have had in your assignments to do. Okay, so let's look at option D, the probability that the primary caregiver works from home, okay, or their child is securely attached. Home is 0.53. Or, let me just read right, or secure is plus 0.56. And then we need to subtract the and. Okay, so that would give us again 0.53 plus that. If I now worked it out correctly, I get something like 0.71. So that is the one that is wrong. What did I get? 0.85. So if you said maybe that plus that minus 0.18, you could have gotten, yeah, I don't know how they got to a 0.85. But that is, so basically take the total of the home, which is 0.53, take the total of the secure, which is 0.56, and then remember, because we have counted in at 0.38 twice, because we've counted it in the home, and we've counted it into the secure, we just need to take one of them away. So 0.53 plus 0.56 minus the 0.38 will give you what I've worked out, 0.71. Okay, so that was the one that was incorrect. And then just let's look at the last one. The probability that the child is securely attached, given that the primary caregiver works from home. So secure and home. So that again would now be the 0.38 divided not by 0.56, but now given the home, so 0.38 divided by 0.53. And that will give us 0.72. So that again is correct. Okay, so this was definitely a bit more tricky. I don't know, you guys can tell me, did you have a question like that in any of assignments, or is this quite new to you in what we've nearly now done? Have you seen such an example before? Because if that is also a very new example, I will see if I can get more of those that I can share with you. Okay. Yeah, so let me see if I can get one or two others like that as well. Just so that we know that you covered, or ones that you get the sample numbers, and one where they give you some of the probabilities already. Okay, so let's go to the next one. So again, looking at exactly the same numbers. Now what they throw in is the other part of study unit 4 that is very important, and that is where we look at things that are complement to one another, independent, mutually exclusive, and not independent. Okay, so that is nearly looking at those 4 things, and we need to look at the data that they give us and see if we can find out one of these things. So let's look at the events secure, and they ask us incorrect. Okay, so they ask us incorrect, so that is also just one to remember. So secure and insecure are complements of each other. Yes, it is. Okay, so secure and insecure will be complements of one another. Home and away will be complements of one another. And how one can see that is, so if you add these two together, the top one we said was 0.56. The bottom one is 0.44. So a complement we know is 1 minus the one element gives you the other element. Okay, so, or if you add the two together, you will always get 1. So between secure and insecure, they are complements, but also between home and away, they are complements. So that is correct. Events, home and secure are independent. So let's rather first look at mutually exclusive. Events home and away are mutually exclusive. So, and the easy way to view it in this format is, can you be home and can you be away at the same time? No. Okay, so then it is mutually exclusive. Can you feel secure and insecure at the same time? No. Okay, so if you look within the variable that was home and away, but those two are mutually exclusive. If you look at between secure and insecure, those two are mutually exclusive, but secure and home is not mutually exclusive. Okay, because you can be secure and at home, because there is 0.38 or 58% of the time happening. But between those two, between secure and insecure, it's 0, and between home and away, it is 0. So, but mutually exclusivity is definitely also correct. Okay, so now we're looking at independent or not independent. Okay, so if I can remember, how do we work out dependent and independent? Sure, what was it? The probability of a one times the probability of the other one is equal to the probability of the and. Okay, let's just do that and over. Okay, hopefully that looks a bit better. So let's look at home and secure. So probability of home, okay, that was, what was that? 0.53 between home and secure, so 0.53 times 0.56. And if that, so home and secure is 0.38, we know the two are independent. So let's 0.53 times 0.56, 0.29 or 0.3. Okay, so they are not independent because those two are not the same. So 0.53 times 0.56 is actually equal to what I've worked out, 0.3, and it's not 0.38. Okay, so it is not independent. So events home and insecure are not independent. Again, we can work it out as 0.53 times 0.44. Let's quickly 0.53 times 0.44. That will give us 0.23. Again, it is not 0.23, so now we can say it is not independent, and that is correct. Okay, so remember, again, we're so used to looking at the raw data or the n values, and then it's sometimes easier to say what's the probability of a one times the probability of the other one. Now we're actually working with the probabilities already. So just make sure that you know how to work with that. Okay, so I think this was again one that was a bit different than any of your other questions. And again, probably you have not seen something like that in one of your assignments. Okay, let me just quickly, I want to just look at one or two other questions that I quickly want to show you guys as well. Because I just saw, I will post the other, so it's all on my YouTube channel. So I will just send you again the link to my YouTube channel on the WhatsApp chat, if that is okay. So I'm now going to not skip between questions, but I quickly want to go back to some of the work we've done because I just spotted it. So let me quickly, because again, I want to show you some of the things to do in Excel. So this should have been part of study unit 3. So, and I will move it into the right slots afterwards in the presentation as well. But basically, yeah, they have given you some of the data, or not some of the data, all the data. What they have given you extra is to say, here is one of the variables. So all they want you to work out that. So again, for me, if I'm looking at this and I need to work out what is the sum of all of these x's, but each time the x squared. So I need to say 29 to the power of 2 plus 30 to the power of 2 plus all of that. So again, this is not something that I really would want to work out with a calculator, because it's very easy. I can make that mistake of saying 1 less 51, and then your whole answer is wrong. So I would rather just want to, again, put it into Excel. So what I'm just now quickly typing is all of those numbers. So 29, 50, 51, 51. So there's 3 times 51, 53, 54, 53. And what is nice about Excel is that you don't need to worry about the order. You can type it in the order that you have it here. Let's just see, there's 3, 6, 9, 12, 15 numbers. Okay, so let me quickly show you. Okay, and let's just make it, see if I can make it a bit bigger. Okay, so it is now. So one can now see here is some numbers that are not sorted. So you can again in Excel go just click on there and say sort, and I want to sort from A to Z. So that tells me from smallest to highest, and there it sorted it out. Okay, so if it was needed or something now that you can work with it as a sorted database, it it has been done. Okay, but when we work it out, you also don't need it to be sorted. So let's just now say, okay, well, I want to do the x to the power of 2. So then it's easy to just say, well, that is actually be multiplied by itself. And we're going to do it for all of them. And then we're just going to do a sum of it. So if we do a sum of that, and you can see here is the sum, so gives you that sum total. So now we don't need it to go on your calculator to say 29 times 29 plus 50 times 50 plus 51 times 51 and done it in Excel. And if we then look at the answers that is in on the table, if we look at the answers, there it is as 17373. So again, if you're comfortable in using your calculator, do it. But if you more likely want to use your Excel spreadsheet, please, because again, it does save time. It just makes it much more easier. And all that I did was also I followed this formula. So I just said, okay, my X number is 29. So I did exactly what I needed to do in Excel. It just makes it easier. Okay, so the next one, very similar. It seems like even the same data. So what they've now done, and you can see through these questions, they nearly showing you the process how to, in the end, get to working out the standard deviation or the variance, because that is nearly the formulas that we are using. But again, so I now have what I need to. So I need to say my X value minus the mean. Again, I will need to calculate the mean, and then I need to do power of 2, and then I need to add all of them together. So again, sure, to do that for 15 numbers is quite a lot. You will probably not get something like this in the exam where it is 15 numbers, but it can be 5 numbers. So that if you want to use other methods, it is actually doable. Okay, so let's move that a bit out. So the formula that I need to work with is, and let's just say the mean, and that I will need to multiply by itself. So let's say times 2. Okay, so now I haven't worked out the mean yet. So let's do the mean, and in Excel it's called average. There isn't a function mean in Excel. So it's the average that we're working with. So the average was 33.8. So let's just call that average slash mean so that you have it as well. So now we can use that in our formula. So we now know that our formula says, okay, I need to say that X value minus the mean. I'm just putting in some. Okay, so that didn't work. It's just dollar. So to put in the dollar sign so that it is, when I drag it down, it doesn't move with it. Okay, so that was my X minus the mean. Remember, I needed to multiply that again by X minus mean, or we can say in Excel, there's a nice function to the power of 2. So that was the mean, the X minus the mean to the power of 2 for the first one. So if we do it for all of them, and we sum that, we will hopefully get one of our answers. So I'm just going to add that sum, because there we also did the sum. So 236.4. Sure. Let's see if that is even on, because that seems so small. Okay, 236.4. Okay, so there it is. What they've done, and you can see with nearly all of these, they've given you exactly the same answers for all of them. So it's very difficult to just guess a number. I think even the next one will be a next set of questions that takes this a bit further. So let's see. Okay, so exactly the same data. Now you need to work out the sample variance. Let's quickly see if the next one is, okay, no, so it's not. Sample variance. Okay, so here they told you, let me quickly check what's the comment. Yeah, what I have seen is not that they nearly do it this way, but what I have seen is that they tell you, they give you this data, and then they say to you, maybe the sum was something and the mean is something. You now need to calculate one other measurement. So they will probably not ask you to this straightforward, because that is just, but if they've given you nearly the information to work out the sample variance, by giving you the one that's on the top and the one that's below it to work it out, that they might do. So that you need to nearly use the information that is from a formula. But we will, and I will share with you that formula page in any case. Yes, and what, so what I've seen, and I don't know in which paper it was, is that they, because you guys can't go back, so what they have been doing in one or two questions was that they link it to one another, but because you can't go back, I nearly tell you in the next question, the sum of the means is this, and they give it to you. So that even if you made a mistake in a previous question of how you calculated it, because you can't go back in your or your exam, because your exams are exactly like your your assignment. So if you're done with a question, it's done. You can't go back to it to revise at all. So if there's information given in the previous question and you need to use it again, what they will tend to do is then give you that information. So that is nearly, if they go through something like this, probably not, let's be honest, but it can be that they do something like this where you needed some of the information you actually will use to work out your sample variance. But then they will actually tell you and give you the right answer. So they will now not expect you to work it out again and then to use it, because that is stupid. It I don't want to say it's only for 1610 because the 1510 guys also need to know it. What I've seen with 1510 is they tend not to go into the detail of the formulas. So, but sometimes there's like one that comes in as a surprise. Um, but most of the time it's more 1610 that goes into the detail of nearly some of those formulas than 1510. So you won't really you won't see 3 or 4 of these at all in 1510. You might get something like this in 1510, but then it might be linked to the mean. So what they can do is, because and that is nearly so, if you needed to work out the mean, it is the sum of, so I now say, sorry, so the sum of the x's so the mean would have been the sum of the x's divided by n. So they could ask you, instead of the sum of xi to the power of 2, they could have asked you to work out that, because then you're actually calculating the mean. So that is more with a 1510. It will be something that makes sense, if I can put it that way, because just to work this out is a waste of time. But yeah, you could see they're working in a format that they nearly want to confuse you because they're always using the same data, and nearly then want to see if you understand what you're doing. But actually, all of that is in preparation of how you're going to work out a sample variance. But there's no ways I'm doing a sample variance the long method. You would see in that sheet that I have shared with all of the study units, there you can put it in the sample variance and all those kind of things. But what I would do if I get a question like this in the exam is I would just go straight to my Excel. I would not go into any of those formulas nearly. I would go straight to say, I need to work out my sample variance. I know that there's a variance formula. variance formula for sample variance is I'm just looking at all those values and where I get my sample variance. I would not, and let's be honest, I don't want you guys to do that as well. Go through this process now, because I think what's the next step is another step I think that you need to do after that. It could just not be the, so to do that another step and then calculate when you can just straight use Excel for the sample variance, please use this. But I know, let me, if you look at that spreadsheet that I have shared, that gives you nearly all the steps also to get to a sample variance. But I won't go into all that detail. If you can just look at the data, ask the Excel formula to work it out for you. And then there is the number of the 16.89. Again, if you said instead of sample variance, population variance, the 15.76 would have been your answer. So if you use Excel, please just make sure that you're using the correct formulas. Okay, because else you're working it out perfectly, you get the answer, you think it's correct, and unfortunately it's not. Even worse is if you went as far to say standard deviation, there is also an answer for you. Okay, so even if you went to that next level of standard deviation, and again, it could be because there was a previous question that you worked out that actually asked standard deviation, and in your mind, that is where you're going. Unfortunately, then there is an answer for you as well. So just, again, with these things, be very careful when we work through it, that you look at the right things. Okay, the other one that they love to ask is coefficient of variation. And it wasn't, I can't even remember if it is really discussed in the study guides. It's it it is in one of the textbooks, but very seldom discussed in the study guide, or it is somewhere, but not that it is nearly there that you would have read it or you might have passed over it. Okay, cool. Was it one of my videos or one of the lecturer's videos? Because then if it was in his video, you know it's important. Okay, because it definitely is one of those that it's nearly creeps. It's hidden in some of the work and the study guides, but it is nearly in every assignment. There's one, and in every exam there is one. Oh, okay. No, he doesn't have an American accent. So, okay, cool. So, yeah, very important that we need to do that. I just now quickly want to see what is that formula again, because coefficient of variation. it is all something like the mean divided by, let me quickly, and if you don't, that is one of the things that we don't really work with a lot, the coefficient of variation. So let me, coefficient of variation. So coefficient of variation is equal to standard deviation divided by the mean. Okay, so again, not that we use it a lot. Okay, so let me quickly, so we're looking at the same data again. It is the mean divided by, which was standard deviation divided by the mean. So let me quickly share that sheet again. Okay, so we again looking at the same data, coefficient of variation. It was, and let's not, it's standard deviation divided by mean. So here we can say standard deviation of a sample divided by the average of a sample. So we can have it all in one. I think we still then need to multiply it by 100 because that is how the formula looks like. Let's see, I don't think there is a coefficient of variation formula, so let's just see. No, okay, so there isn't. So the answer would have been 12.15 or 12.16, but let's just still, if you looked at what the standard deviation, again, just let's do that for you guys. So if that was the standard deviation that we calculated, there was the mean, it would have been standard deviation divided by that mean. And if we multiply that by 100, we should then also get the same answer. Okay, so 12.16. So if we go to the presentation again, and if we look at it is 12.16. If again you used the population, your answer would have been 11.75. So again, very careful between the two. If you use population, it would have been 11.75, but actually, and where they tell us it's sample data. So we need to, when we work the standard or the variance, it will be the sample variance. When we look at the standard deviation, it will be the sample standard deviation, so that when we go to coefficient of variation, remember when we divide it, it is divided by the sample standard deviation. Okay, very important, because again, just by making that slight difference from sample to population, unfortunately, we get the wrong one. Okay, so this is nearly where we will stop tonight. So let me stop sharing. And I will, and let me stop as well, and then we can just chat a bit, as don't need all the chat on the recording. So I will schedule for us